It feels like just yesterday, we were all marveling at chat bots that could answer simple questions. Now, the buzz is all about AI. They can actually do things, plan, reason, execute complex tasks almost on their own.
Yeah, it's moving so fast.
It's a wild frontier. And if you're anything like me, you're trying to wrap your head around how it all fits together.
Absolutely. The speed of development is incredible. And for you, trying to understand this evolution, it can feel like a deluge of information.
Totally.
But don't worry, we've got something that will act as your guided tour through this complex world.
Exactly. We're diving deep into the AI agents market map created by Dave Davies. Think of it as our key to unlocking the inner workings of these autonomous systems. We've gathered a wealth of information that breaks down this entire ecosystem into understandable parts.
And our goal today for you is to navigate this map without getting bogged down in, excessive technical details. We want to provide you with a clear grasp of the fundamental layers that power these intelligent agents. Consider this your fast track to being well informed about this cutting-edge field.
Okay, let's explore this map together. It's structured in layers, starting with the absolute foundation.
Yeah, the real basics.
We're talking about the core technology, the actual hardware that enables all this AI innovation. That's our first stop, GPU, CPU.
This layer is truly the bedrock. Without the sheer processing capability, the sophisticated AI we're discussing simply wouldn't be possible.
Makes sense.
And when you look at the dominant forces here, several key players immediately come to mind. The crucial insight here is the strategic importance of parallel processing in accelerating AI development.
Absolutely. You've got NVIDIA, the clear leader in AI accelerators. Their high-performance GPUs like the A100 and H100.
Those are everywhere.
Along with their CUDA ecosystem, which, in essence, provides the tools and environment for developers to harness that GPU power. And their hardware specifically optimized for what are called transformers have become foundational for so much of modern AI.
It's hard to overstate their impact, really. Their early bet on parallel processing for AI workloads, well, it created a powerful advantage.
And right there alongside them, you have AMD.
Yep, AMD. Major producer of both CPUs with their EPYC line and GPUs with the Instinct series.
So they're competing strongly.
Oh, yeah. They're providing significant competition in the data center AI space, offering robust alternatives. This competition is really healthy for driving innovation and providing you with more choices.
And then there's Intel, the established CPU giant.
Right, Intel. Their Xeon processors power the vast majority of AI servers globally.
Still dominant there.
For sure. But it's fascinating to see them also developing AI-specific hardware like the Habana Gaudi accelerators, demonstrating they're actively adapting to this rapidly evolving landscape.
It seems like everyone's jumping in.
Well, what's particularly interesting is the emergence of these innovative startups as well. They're pushing the boundaries with specialized hardware architectures tailored for specific AI tasks.
For sure. You've got CoreWeave, a cloud GPU provider offering on-demand infrastructure.
Making that power more accessible.
Exactly. And Grok, with their LPU, the language processing unit, that's all about achieving ultra-fast AI inference.
Inference being when the model is actually doing its work.
Right, generating answers, predictions, that kind of thing. Grok's focus is on making that happen incredibly quickly, which is vital for many real-world applications.
And let's not forget GraphCore, the developers of the IPU, the Intelligence Processing Unit. Yeah, specifically designed for highly parallel AI processing. Think of it as a chip architected from the ground up to handle the unique demands of AI computations. Or Cerebrus systems, who are doing something truly unique with their wafer-scale engine, essentially a single massive chip offering extreme parallelism for training those enormous AI models.
Wow, a whole wafer as one chip.
Pretty much. It really gives you a sense of the diverse and innovative approaches being taken at the hardware level to power this AI revolution.
Okay, so we've got these incredibly powerful engines. Now, where do we put them to work? That brings us to our next layer. Base infrastructure.
Think of this as the essential environment where these powerful chips can operate at scale and with reliability.
The plumbing, almost.
Kind of, yeah. It's the foundational layer that allows AI applications to be deployed, managed, and accessed effectively by you.
And the big names here are likely familiar. AWS, Microsoft Azure, and Google Cloud.
The big three cloud providers.
They're the leading cloud platforms, offering that crucial scalable computing, meaning you can easily increase or decrease the resources you need.
Super important for handling variable loads.
Along with specialized AI services and on-demand access to those powerful GPUs and even Google's own TPUs. They truly are the backbone for hosting so many AI applications we encounter daily.
Absolutely. And beyond just the cloud platforms themselves, you have essential supporting tools. Docker, for instance.
Containers.
Exactly. Docker allows developers to package their AI models and agents with all the necessary software and settings they need to run, ensuring they work consistently no matter where they are deployed.
Like packaging an app with all its toys so it works the same way on any computer?
That's a great analogy. And then Kubernetes takes those containers created by Docker and automates their deployment, scaling, and management.
So if your AI application suddenly gets a lot more users,
Kubernetes can automatically spin up more containers to handle the load. It's like the conductor of the AI infrastructure orchestra, especially when you're dealing with distributed training or deploying AI as smaller independent services.
right, managing the complexity.
What's also interesting are some of the more specialized tools emerging in this space. Hugging Face's TGI, for example.
Text generation inference.
Yep, specifically engineered for high-performance, large language model text generation, or SLRM, which, while it's been a key player in high-performance computing for years, is still crucial for scheduling those massive AI training jobs across vast clusters of computers.
So tools for specific jobs within the infrastructure.
Precisely. And we can't forget VLLM, an open-source LLM inference engine focused on maximizing throughput, essentially how many requests the model can handle efficiently.
Making it cheaper to run.
Making model serving more cost-effective. Exactly. And RayServe offers that scalable inference with dynamic routing, ensuring user requests are handled optimally across available resources.
A really vibrant ecosystem of tools supporting the underlying infrastructure, making it easier for developers to build and deploy AI applications for you.
So with the powerful hardware and scalable infrastructure in place, we arrive at what many consider the brains of these autonomous agents, foundation models.
Okay, the actual AI models themselves.
Exactly. The key insight here is that these models provide the general intelligence that allows agents to understand and interact with the world.
These are the massive pre-trained language models that provide the cognitive power for these next-generation AI systems. And you've got some real giants leading the way in this space.
Leading the charge, of course, is OpenAI, the creators of GPT-4.
Name everyone knows.
Pretty much. They're widely recognized as pioneers in the LLM world, and their API access to models like GPT 3.5 and GPT-4 has really fueled an explosion of AI applications that you might be using every day.
And then you have Anthropic.
Right, founded by researchers with a strong focus on constitutional AI and safety.
Safety first, basically.
That's their angle. Their model, Claude, is designed with principles of being helpful and harmless in mind, which is becoming increasingly critical as these models become more integrated into our lives.
Definitely important.
Google DeepMind, with models like PaLM and their latest, Gemini, are leveraging Google's vast computing resources and DeepMind's cutting-edge research.
Bringing Google's scale to bear.
Their models are increasingly integrated into Google's products and services.
And then there's Meta AI, who have taken a really interesting approach by open-sourcing their Llama series of LLMs, most notably Llama 2.
That was a big deal, the open sourcing.
Huge. By making the code and model weights publicly available, they've really empowered a much wider community to build upon and fine-tune these powerful models.
Absolutely. And you have companies like Cohere and AI21 Labs providing access to their LLMs via APIs, really targeting enterprise applications.
More business-focused.
Yeah, they offer alternatives to the major players, often specializing in areas like text generation and understanding for business use cases.
And it's exciting to see newer players like Mistral AI out of Europe.
Mistral, yeah. They released the open source Mistral 7B model, demonstrating that smaller, more efficient models can still achieve impressive performance on many tasks.
Efficiency matters.
It really does. And DeepSeek, focused on delivering cost-efficient, high-performance open-source language models, is another compelling alternative. It's a rapidly evolving and competitive landscape.
Which is good for users, right?
Ultimately, yes. It benefits you through more options and faster innovation.
Okay, so models are the brains. But brains need memory, right?
Exactly. For these brains to truly function effectively within autonomous agents, they need to be able to remember and understand the vast amounts of information they encounter. That's where our next layer comes in. data storage.
Makes sense.
The crucial insight here is the need for specialized databases that can handle the unique ways AI agents process and retrieve information.
We're talking about robust database solutions that allow AI agents to persist information, retain context across interactions, and store those crucial numerical representations of meaning called embeddings.
Embeddings, yeah. And a key development in this layer has been the rise of vector databases.
Vector databases, what's special about them?
Well, they're specifically designed for what's called similarity search based on those vector embeddings. Imagine organizing books not just by keywords in the title, but by the underlying topics they cover, even if the words used are different.
Ah, okay. Based on meaning, not just words.
Exactly. Vector databases do something similar with data. Companies like Pinecone, Weaviate, Chroma, and Qdrant are at the forefront, providing both fully managed services and open source tools that enable incredibly efficient semantic search.
So instead of just finding documents that contain the exact words you search for, these databases allow agents to find information based on its meaning.
Which is absolutely crucial for understanding context and reasoning effectively.
Got it. What about other types of storage?
We also have traditional document stores like MongoDB, which is excellent for storing unstructured data and the overall state of an agent.
Like saving its progress?
Yeah, that sort of thing. And Redis, often used as a super fast in-memory cache, including for temporarily storing those vector embeddings for quick access.
For speed.
Exactly. And it's worth briefly mentioning graph databases like Neo4j and TigerGraph.
How do they fit in?
While the market map lists them as additional, they are incredibly powerful for building knowledge graphs and understanding complex relationships within data.
Like connecting the dots between different pieces of information.
Precisely. An AI agent could use a graph database to understand the connections between different entities and events, which can be very valuable for certain types of reasoning tasks.
All right, so we got the processing power, the infrastructure to run it, the intelligent models, and the memory to retain information. Now, how do we put it all together to create these sophisticated workflows?
Good question. That's where orchestration comes in.
Making it all work together.
Pretty much. The core insight here is the need for tools to manage the complex interactions between different AI components. These orchestration frameworks are the tools that allow developers to build, manage, and optimize those complex AI workflows.
They conduct the whole show.
You could say that. They essentially choreograph how the foundation models interact with the data stores, security tools, and even the model routers we'll discuss shortly.
Okay, who are the key players here?
There are some really pivotal players in this layer. LangChain is a major one, an open source framework that provides all sorts of building blocks for composing prompts, creating chains of actions, and enabling agents to use external tools.
Sounds flexible.
It offers a huge amount of flexibility for integrating LLMs into various applications. Then there's Llama Index, formerly known as GPT Index.
I remember GPT Index.
Right. It's specifically focused on retrieval augmented generation, or RAG.
RAG. That's giving the LLM outside knowledge.
Think of RAG as giving the LLM access to a specific set of information before it answers a question, making its responses more accurate and grounded in that data. Llama Index provides the tools to build those connections between LLMs and external data sources by creating efficient indexes.
Makes the answers better, basically.
Hopefully. Haystack is another powerful open-source Python framework, particularly well-suited for building production-ready LLM applications, especially question-answering systems.
For production systems?
Yeah, it streamlines the process of orchestrating those RAG pipelines and integrating all the necessary components in a robust way.
Any others?
And we're also seeing the emergence of platforms offering different approaches to orchestration. Letta, for example, focuses on building stateful AI agents that can maintain context and long-term memory across conversations.
Agents that remember.
Exactly. And Orche.ai provides a no-code platform for building and managing what they call digital coworker agents, aiming to make AI agent creation more accessible.
No code is interesting.
Definitely lowers the barrier to entry.
What about weights and biases? WMB Weave is mentioned here, too.
Ah, yes, WMB Weave. What's particularly compelling there is that it's described as an end-to-end LLM ops platform for developing AI applications.
LLM ops. Like DevOps for language models.
Kind of, yeah. What's really neat is how Weave brings together experiment tracking so you can see how different versions of your AI are performing with the dataset versioning, and these really interesting specialized features like traces, evaluations, and guardrails.
So more than just orchestration.
Exactly. It really feels like a central hub for not just building, but also deeply understanding and ensuring the safety of these LLM-powered applications.
That sounds pretty comprehensive.
It acts as both an orchestration layer, helping you define those workflows, and an observability layer, letting you see exactly what's happening under the hood as you refine your prompts, assess the outputs, and even enforce safety measures, all within a unified environment.
Okay, that connects a few dots. Now, what about choosing which model to use? There's so many now.
Right. As the number of powerful models continues to proliferate, the challenge becomes, how do you ensure the right query gets to the most appropriate model for the task at hand?
Yeah.
That leads us to the layer of model routing. The key insight here is optimizing performance and cost by intelligently directing requests.
Like a traffic controller for models.
That's a good way to put it. These tools are all about intelligently directing queries to the best model or API endpoint for the specific job, taking into account factors like performance, cost, and even real-time availability.
Makes sense. Who does this?
You've got Martian, for example, offering an LLM model router that can automatically select and switch between different models based on criteria like latency and cost effectiveness.
Automatic switching, cool.
OpenRouter provides a unified API, allowing you to access a wide array of major LLMs through a single consistent interface.
One API for many models.
Exactly. And LeetLM is an interesting open source gateway and SDK that standardizes how you interact with over 100 different LLM APIs.
Over 100? Wow.
Yeah. It even includes features like automatic fallback to alternative models if one is down or responding slowly. It really simplifies working with multiple LLM providers and adds a layer of resilience.
That seems super useful. Okay, so models are running, requests are routed. How do we know if they're actually working well?
Crucial question. Once you have these models and agents running, it's absolutely critical to understand how they're performing and to continuously improve them.
Right.
That brings us to the closely related layers of LLM observability and evaluation. The core insight here is the necessity of monitoring and rigorously testing these complex AI systems.
You need to see inside the black box, basically.
You need to be able to see what's happening inside these complex systems to monitor their behavior, identify potential issues, and debug any problems that arise. And you also need systematic ways to test their performance and measure their effectiveness against specific goals.
Okay, what tools help with observability?
On the observability side, LangSmith, created by the developers of LangChain, provides a unified platform for exactly that, gaining visibility into your LLM applications.
Makes sense, connected to LangChain.
And building on this, WMB Traces, a feature of weights and biases, allows you to capture incredibly detailed logs of every interaction within your AI agent.
Like a step-by-step replay.
Pretty much. This step-by-step visibility is invaluable for debugging even the most intricate reasoning processes and understanding exactly how your agent arrives at its conclusions. That seems really powerful for fixing things.
And WMB agents, is it related?
Yeah, WMB agents takes this a step further, specifically focusing on tracking the internal state and the decision-making process of autonomous agents.
So why it made a choice?
Exactly. It really helps you analyze why these agents are making certain choices and pinpoint areas where things might be going wrong.
Very cool. Other observability tools?
We're also seeing other excellent tools like Traceloop, an open source platform for monitoring LLM applications in production environments.
Production monitoring.
And Helitone, which provides a dashboard to visualize all your LLM requests and responses, making it easier to spot trends and potential issues. Platforms like Arise Observe and YLabs also offer comprehensive solutions for evaluating and monitoring LLM performance, including detecting problems like factual inaccuracies or unwanted biases.
Lots of options there. What about the evaluation part? Testing them.
Good point. When it comes to evaluation, OpenAI Evals provides an open-source framework for benchmarking LLM performance across a wide range of tasks.
Benchmarking, okay.
RIGAs is specifically designed for evaluating those retrieval-augmented generation pipelines.
Checking if the RAG part worked.
Ensuring the LLM is effectively leveraging the retrieved information in its responses. And WMB Evaluations offers a powerful toolkit for rigorously testing your LLMs and agents.
How does that work?
It allows you to define your own custom metrics and track performance over time, bringing a level of rigorous testing and measurement to the world of LLMs. Really helps you quantify improvement.
That sounds essential for development. Of course, with systems as powerful as these, ensuring security and safety is absolutely paramount.
Couldn't agree more. That's our next critical layer, LLM security.
Yeah, this feels really important.
Absolutely. The core insight here is the need for proactive measures to protect against vulnerabilities and harmful outputs. We need robust tools and platforms that can protect against things like prompt injection attacks, sensitive data leakage, and the generation of toxic, biased, or otherwise harmful content.
So stopping bad inputs and bad outputs.
Basically, yes. And WNB Guardrails really stands out in this area.
Another WNB feature. How does it fit in?
It provides these out-of-the-box safety and quality checks for both the inputs and outputs of your LLMs. It can automatically detect things like toxicity, bias, personally identifiable information, PII, and even potential hallucinations or made-up information.
Hallucinations are a big problem.
They really are. And guardrails can be configured to either block or modify unsafe outputs. It's a really proactive and crucial layer for building responsible AI applications.
That seems very useful, having that built-in protection.
Definitely. You also have dedicated LLM firewalls like LLM Guard, which helps to sanitize and secure the interactions between users and LLMs.
A firewall for language model.
Exactly. Y Labs also integrates security features alongside their observability tools. NVIDIA NeMo Guardrails provides an open-source toolkit for adding programmable rules and constraints to LLM conversation.
Programmable rules, okay.
And Lakera Guard focuses specifically on detecting and preventing prompt injection attacks and protecting sensitive data. Even tools like Burp GPT, which brings LLM capabilities to the Burp suite for web security testing, highlight the growing importance of security considerations in this evolving landscape.
Security is definitely key. Now, one of the fundamental limitations of even the most advanced language models is their context window.
Right, how much they can remember at once.
Exactly, the amount of information they can effectively process at any single point in time. To overcome this and enable truly stateful and long-running interactions, we need memory.
Makes sense. The core insight here is the need to extend the short-term memory of LLMs. These are systems specifically designed to extend an LLM's effective memory by allowing it to store, retrieve, and update information across multiple interactions and over longer periods.
So giving them long-term memory. How?
Well, MEN is a dedicated memory layer specifically built for LLM applications, allowing developers to programmatically manage and access memories, enabling things like maintaining context in long conversations.
A dedicated layer just for memory.
Yep. Cogni takes a slightly different approach, functioning as an open-source AI memory engine that transforms raw data into more structured forms of memory, like knowledge graphs and vector indexes, which LLMs can then readily access and reason over.
Structuring the memory.
Right, and as a common and practical approach, many frameworks, like LangChain with its memory modules, implement various long-term caching mechanisms, often leveraging vector databases or other storage solutions to supplement the LLM's inherent context window.
Using the storage layer we talked about earlier.
Exactly, tying it all together.
Okay, this is building up nicely. We've gone from hardware all the way to memory. What's the final piece?
Finally, we arrive at the pinnacle of this layered ecosystem. The agentic system itself.
The agents.
This is where all the individual layers we've discussed seamlessly come together to create truly autonomous AI agents capable of performing complex tasks.
These are the systems that can independently plan, reason, and execute multi-step tasks with minimal human oversight.
Right. They represent the culmination of all this incredible technological innovation.
What are some examples?
We've seen fascinating examples like AutoGPT.
Oh, yeah, that went viral.
It really captured public attention with its ability to autonomously chain GPT calls for complex task planning and execution. Baby AGI was an earlier, more experimental framework focused on the fundamental aspects of taskless management for an AI agent.
Simpler, maybe.
A bit more foundational, yeah. Crew AI enables the creation of multi-agent systems where multiple AI agents can collaborate and work together on a shared goal.
Agents working in teams.
Exactly. And Agent GPT provides a user-friendly, web-based platform for easily configuring and deploying these autonomous AI agents.
Making it easier to build them.
Trying to, yeah. And companies like Adept AI are pushing the boundaries even further, focusing on building a more general form of intelligence that can actually utilize existing software tools and interact with computer interfaces in a way that mimics human users.
Wow, AI using our regular software.
That's the goal. It offers a glimpse into a future where AI can truly act on our behalf in more sophisticated ways.
That's quite a journey through the layers.
So as we reflect on the AI agent's market map, it becomes clear that this isn't just a collection of isolated tools, but rather a deeply interconnected and increasingly integrated ecosystem.
Everything relies on everything else.
Pretty much. Each layer we've explored plays a vital role in the ongoing development of these intelligent autonomous systems that are poised to reshape how we interact with technology.
And for you, listening, gaining an understanding of these fundamental layers provides a truly valuable perspective, not only on where the field of AI stands today, but also on the exciting trajectory of its future. It offers a framework for comprehending the ongoing evolution of AI and intelligent automation.
This raises a crucial question for you to consider. As these diverse technologies continue to integrate more seamlessly, how will this fundamentally alter the relationship between humans and machines?
Yeah, that's the big question.
What novel applications and opportunities might emerge as these systems become even more sophisticated and interconnected? We encourage you to further explore the specific companies and tools we've highlighted today that have particularly sparked your curiosity.